Ladies and gentlemen, this is J-Point 2021, and let me introduce you Mr. Dmitry Alexandrov and Dr. Venkat Subramaniam. Mitya, Venkat, welcome to our broadcast.
Hello.
Yes.
Hello.
Mitya, could you please say a couple of words about yourself, and could you please introduce Venkat?
I will stay humble, just a software developer, writing code, talking, giving talks sometimes, but I'm really excited, I would say, and this is a great honor for me to present to all of you somebody I can call my really good friend, first of all, and a person who I can speak a lot and who knows so much, and from whom not only me but every one of you can learn really a lot. And I believe that today is just a great day to learn from him really new stuff. So great pleasure to introduce you, Dr. Venkat Subramaniam, my good friend. Hello, how are you?
Good, very good. Thanks so much for having me here. I'm excited to be talking about something that is going to influence the way we write code in Java. All right, so let's get started. Well, welcome to the talk on type inference.
Just a second.
Oh, yeah.
Yes. Could you please give us a couple of more minutes? Because, as I usually do, I want more people in our Telegram chat. Again, our attendees, just under the player, you have several buttons. One of these buttons is Telegram button. This is a short way to join our chat when you can ask some questions in Russian or English or some other languages if you prefer. And Mitya will translate all these questions to Venkat. So, and now I have yes, Mitya. Do you see this chat, correct? So I'm
yes, I can see people are joining.
How many people do you have? So
I have, just go ahead.
I have only 30. I think it's not enough for start. I need more. Yes. I need more.
I'm sure people are watching them, but they're not joining the chat. Yes, exactly. But
we are waiting for 50 people to start. Okay, 50 people. Okay, now we have 30. How many do we have, Mitya?
It's refreshing. 32 on my side. Yep. 32. Wait a minute, it stopped refreshing. Let me do it again.
Okay, people joining.
Yeah, that's definitely not an opportunity to miss.
Yeah, okay, one more thing, just let people join. Venkat, could you please say a couple of words about what is your talk about? Just maybe a couple of phrases or things like that.
Yeah, so people are often scared about type inference. They are a little bit apprehensive about using it. So I want to really talk about where it really has been around for a while and it's only getting better.
Good, thank you. Okay, people join. We have 40 people. So okay, ladies and gentlemen, Mr. Dmitry Alexandrov and Dr. Venkat Subramaniam, Java champion, Java 1 rockstar, etc., etc., etc. Dear Venkat, it's a great honor for us to have you on board this year, and the broadcast is yours.
Thank you. I want to encourage people to ask questions along the way. So I'm thankful for Mitya to be there to take the questions and read it out along the way and translate where necessary. So please don't hesitate to ask questions. Just about anytime you have a question or comment is a great time for your questions or comments. So let's talk about type inference. I'll start with a little story. I was going to give a talk in the Dallas Java user group. And I was like, what should I talk about? And I decided that I will talk about type inference. And then when the time came to give the talk, I realized, what can you talk about type inference? Maybe I can give a talk for 2 minutes, right? Well, Java has type inference. Here's how you can use the var keyword. Well, thanks for coming. Well, that's when I realized I'm going to give a talk for an entire 90 minutes. And when I went there to give the talk, The talk actually went for 120 minutes. People were really excited about this particular conversation. And there were people who were against a type inference, people who were opposed to type inference. So this is one of those heated topics. I did not realize how heated it is until I really started giving the talk. So let's talk about type inference. I want to talk about whether it's a friend or a foe. Well, type inference is really a characteristics of statically typed languages. Now, as we know, when it comes to programming languages, we have static type languages, dynamic type languages, we have strongly typed languages and weakly typed languages. But it turns out with all these different variety of languages that are out there, that the word static typing is not a point actually, it's more of a spectrum. So for example, to say that Java is statically typed like Haskell is doesn't really make any sense, because Haskell is a much more rigorous statically typed language compared to Java itself, for example. But nevertheless, type inference is characteristics of statically typed language. And when it comes to static type languages, there are some static type languages that offer type inference from day one. For example, languages like Haskell and Scala and Kotlin have been providing type inference from the beginning, from the get go. But on the other hand, languages like C Sharp and C++, and more recently Java, have started providing type inference much later in their life cycle. Now, when it comes to Java, though, it turns out that Java has actually had type inference for a while, and way back starting in Java 5, for example, and slowly but surely, they've been introducing more and more type inference. The time we saw this predominantly, I would say, is in Java 8, and that's only becoming more prominent thanks to the type inference capability in Java 10. But a lot of people started noticing it in Java 10 because of a different syntax. But to be fair, it's been around for a while, and we have been using it quite a bit along the way. Now, it's really important to understand what type inference can do for us. It's also important for us to understand what it cannot do as well, so that we are able to use it to the best we can. Now, let's talk about type inference in Java over the years. Now, remember, Java 5 introduced the concept of generics. And generics, of course, gives us the ability to write code, but we don't have to be saying what the type is and do casting as much. Generics really eases the pain for us quite a bit. And of course, we can use generics in the code quite often. For example, if I were to say list of integer, for example, we'll say numbers is equal to new array list of integer, let's say. And once we create this array list, we can say numbers.add, and we can add a 1, for example, and we can output the numbers right there. And you can see that the output shows the value of 1. But if you were to add, let's say, numbers, let's say, dot add, and I had a hello, now obviously the collection, the generics will not permit you to add a string, for example, and you're going to get a compilation error. Well, the add function clearly in this case knows that it's going to permit only an integer and not a string. And when you receive a data from this particular object, it knows to really return an integer for you. So as a result, the generic type removes the burden of casting and transforming the data over and over. So we can see the type inference kick in quite a bit. But of course, one of the problems with that is the type inference, while it's really nice, the type information is needed occasionally when things get really complicated. You probably have seen situations where you had to really provide the type information, not in this particular case, obviously, but occasionally you may have to really do this. So this is an example where you had to specify the type inference for this add function to indicate that the type is an integer, and you use that syntax. Like I said, you don't do this for simple cases, but occasionally you will have to provide that when the situation is so complex that the language, the compiler is not able to infer the type for you. Now, Java 7, of course, went a little bit further with type inference by having the diamond operator available for us. So what you can do in Java 7 is you could get rid of this integer from here so you don't repeat it twice in the code. So you have to say list integer numbers is equal to new array list. But Java 7 had a limitation. In Java 7, you could not implement an anonymous inner class like so. This syntax will not compile in Java 7, but that was fixed in Java 9. In Java 9, you are allowed to have anonymous inner classes with the diamond operator. That is absolutely permitted. Now, as you can see, the type inference is slowly but surely improving in Java over the releases. Java 8, of course, had a very important type inference, which is the Lambdas had type inference capability. So going back to
Just
this
Venkat.
particular, yeah, please.
Yeah, one small question.
Sure.
Which actually editor are you using right now? Because people are wondering how easy you can do this. Have you changed it recently, by
Yes,
the
I
way?
have. Actually, this is entirely VI. That's what I'm using. So
Yeah,
pretty much VI is what I'm using for both the list over here and the code here, and then I'm just firing it up and executing that using a few different shell scripts in the background.
lovely. So once again, VI, this is how the gurus do it. Yeah, thank you.
So in this case, when you have the lambdas, you could have written the code like so. For example, you could have said, for example, numbers dot for each, and within the code, you could have said integer over here, and then you could have said the element coming in, and then of course the lambda, and you could have output the element that you have receiving. Now, while this is something you could potentially do where you could ask for the numbers dot for each, as you can see in here, receiving the numbers collection, calling the for each method on the integer e, and then trying to output the value in that particular collection. But the point really is that information is redundant. Why? Because it's very clear for us to know that in this particular case, of course, I'm going to go ahead and output the numbers, let's say dot add. Well, actually, let's do it a little differently in here. Let's go ahead and take this collection and say arrays dot, let's say as list, and let's say 1, 2, and 3 in here. So when we execute it, it uses the data 1, 2, and 3, but that information integer is entirely redundant. If you're going to put your hands into a collection of numbers and take an element out, guess what that element would be? A puppy, a kitten? No, it's going to be an integer. So why bother specifying that it is an integer that is redundant? So as a result, you can get rid of that integer right like so, and that is type inference. But make no mistake, the compiler clearly knows what the type of the integer of the variable really is. So as an example, if you were to go back here and say dot foo, notice what the error message looks like. It says method foo is not found on a variable e of type integer. So clearly the compiler knows that the type of the variable is an integer without we having to say it, and that is basically type inference. So in other words, in Java 8, parameters to lambdas were inferred automatically for us, and that is one of the benefits we got from this. But of course, that has some limitations as well when it comes to type inference. For example, in Java 8, again, this has been fixed later on, but in Java 8, one limitation was when you use type inference, you could not use annotations like final or some other annotation. So for example, if I had it as integer right here and element e like so, then what I can do is I can potentially say, for example, final right there if I wanted to. Or I can potentially also say something along the lines of not null. For example, if I wanted to bring in and use Java X dot, let's say validation dot, let's say constraints, and I can bring that in and I can use the constraints as well if I really wanted to. However, if I'm going to use type inference like so, where I have the element e and its type inferred, Unfortunately, when I use type inference in Java, I could not use annotations. I cannot place final. I cannot also use annotations, if you will, like a not null. For example, in this case, if I say not null, the compiler will not accept it. So that was a limitation. Now, the good news is that limitation was removed in Java 11, but we'll talk about that later on. So that's one limitation. But there's also another limitation we need to keep in mind. When there is not enough context, type inference will not work. Now, this is important to keep in mind because there are times when I've heard developers say, well, gosh, Java is stupid. No, Java is not stupid. We haven't understood how type inference actually works. And when we don't understand how type inference works, it can be very frustrating for us. So I want to give you an example of why you will run into situations like this. So let's take an example of, let's say, a collection of people that I want to work with. So in this case, let's say I'm going to bring in a create person dot, a little bit of a Java code. So you have a collection of people right here like so. So I'm going to say create people, and I'm going to call a stream on it. And then I'm going to say sorted. And once I do the sorted, I'm going to say for each, and I'm going to print out the object or the results of that particular call. But what am I going to do for the sorted? Well, for the sorted, I'm going to say that I have a person. Well, first of all, you could use comparing, and I can specify in this case a person. I'll say person, and this is going to simply say person dot get name, and I'm going to compare it based on the name of the person. So what is the where does the comparing come from? That's a static import from the comparator. So comparator dot star, and that's where the comparing really comes in. And you can see the data got sorted. Now, when you look at this code, you say, oh, look at that. For the lambda expression, you specified the type of the parameter person. Sure enough, but you can also do it like so. You can remove the person type from this code, and you can simply pass the person instance, the variable parameter directly. Notice the code actually worked, not a problem. So we used a type inference instead of specifying the type. Well, that's awesome, but let's go a little further. What if you were to call a create people? Once again, you call a stream on it, but this time what I'm going to do is to call the sorted, but I'm going to say comparing, and I say person, like so. But then I'm going to say, after I call the person comparing, I'm going to go back and say over here, dot reverse. So reversed is going to reverse the order for us. So notice this is the reverse order of the person. Now, when you look at this code, you say, all right, the code actually worked, but why not use type inference one more time? So in this case, if I go back and remove the type for the person, what's going to happen? When I remove the type for the person, unfortunately, notice the code did not compile. But look at the error. The error says method get name not available in the variable of type object. Wait a minute, where did object come from? This can be very frustrating if we don't understand the reason the compiler failed at this point. Look at the line numbers that you have in here. Look at line 20 and compare it to line 24. In line 20, we were able to use type inference, but in line 24, we are not able to. The question is, why? Well, keep in mind, type inference works based on the context. If it doesn't have the context, it cannot do its job. So it turns out what's happening is when you call comparing on the person, it doesn't know what person is. So the compiler says, hey, comparing, what are you looking for? And the comparing says, I want to take as an argument, the comparing says, I want to take a comparator of type D. And the compiler says, but I don't know what type D is. Let me look at my neighbor. Let me look at the context. So it goes out to sorted because the neighbor of comparing is sorted. And it says, hey, sorted, what do you want? And the sorted says, the sorted says, on a stream of person, I want to take a comparator of person. So the compiler says, aha, now I know what T is. T is actually a person. That's how it knows the type. Unfortunately, though, when you look at this code now, the comparing says, I am going to take, well, actually, to be fair, this is going to take a function, if you will, which is of type T comma R, just to be correct. And that's going to return a comparator, if you will, a comparator of type T. And of course, it doesn't know what T is in this particular context. But it was able to find that out based on the person. Now, on the other hand, when you look at the comparing right here, and the compiler says that's going to take a function of T comma R, if you will, but that's going to return a comparator of course, comparator of type T. And the compiler says, I don't know what T is. Let me check with my neighbor. Well, remember what the neighbor of comparing in this example is. The neighbor of comparing is reversed. So what does the reverse to say? The reverse to says on a comparator of type T, reversed will return back to you a comparator of T. Notice how this becomes circular. When you have a type T, that becomes a type T, and the compiler is like, I cannot look at my neighbors and find what the type T is, so it gives up and says, sorry, I can only infer the type T to be a object and not really a person in this case. So understanding how type inference actually works makes us better programmers because we are able to deal with situations like this one where we see the type inference doesn't work and we don't get frustrated because of that. So we talked about type inference, and one thing we need to keep in mind is type inference relies upon the context, and that is something we need to absolutely keep in mind. Given that, of course, Java 9 introduced one small benefit, and that is anonymous inner classes can be used with type inference when it comes to generics. So, for example, if I say integer, and if I say numbers is equal to new array list, and if I were to write an anonymous inner class, this is okay, okay starting, if you will, Java 9, but that code will not compile before the time of Java 9. Because before the time of Java 9, you cannot have anonymous inner class with the diamond operator. So that restriction has been removed in Java 9. Well, so that is what we had before the time of Java 10. Java 10 obviously introduced the var. So what's happening with var? Java 10 has local variable type inference. So what is local variable type inference? If you are defining a variable as a local variable, so string greet is equal to, let's say, hello, and I want to output the variable greet. So when I run the code, you can see it said hello. Now, rather than doing it, what is the type of greet? Well, why the type of greet is a string. But how do you know? Not because you said so, it's also because of what you assigned to that variable. So as a result, you can remove the type information from here and you can simply specify a var. So what does this really do? You're telling the compiler, hey, compiler, do me a favor. I want you to infer the type of greet based on what I assign to it. But we have to understand what var really means. Keep in mind, var is is for type inference, and keep in mind, type inference is a feature of statically typed languages. Sometimes people tell me, oh my gosh, you're using a var to define a variable. Java now is like JavaScript. Java can never be as evil as JavaScript. So we should never say such things. So in this case, a var simply says, go ahead and infer the type of the variable. Keep in mind that type inference happens at compile time, and there is no overhead during runtime. So in that regard, here's the way I define var. Var is a wink at the compiler. So it's a wink at the compiler. You as a programmer are saying, hey Java, I know what the type of greet is. You know what the type of greet is. If you still want me to say what the type is, I will. And then you wink and say, but I think you can figure it out. So it's literally a wink at the compiler. Now, what is important to keep in mind is this is purely a convenience for us, the programmers. The compiler will, at the bytecode level, put the type of the variable based on what it really is. So to emphasize this, let's take a look at an example. So I'm going to run the code like so. You can see it produced hello. But let's go over to the command prompt for a minute. And on the command prompt, I'm going to go over to where the Java code is. Java C -d temp classes, and I'm going to compile the sample.java. Now that I compiled it, I'm going to say Java P -c -v. All those options are aliases on my machine. So I'm going to say Java P temp classes sample.class, and I'm going to take a look at the bytecode that got generated. I'm going to leave this bytecode here so we can take a look at it. But what I want you to see very clearly here is line number 11. Notice it says a string hello right there is what you see as the type of that particular variable. So the compiler knows the type of hello is string, but of course we specified it explicitly in the code as well. But having said that, let's now go back and define this as a var right there. Now that I put a var instead of string, if I go back to the command prompt, I compile the code one more time. I recompiled it. I used Java P to fire up and look at the bytecode. Now, notice the line that is highlighted is the old code. This one is the bytecode from the newer version. Did you notice there is absolutely no difference between the bytecode at all? On line number 11, the type was a string when I used the type explicitly. On line number 11, the type is still string when I used var. So the compiler infers the type, and at the bytecode level, the type still exists. There is absolutely no runtime overhead. The inference happens during compile time, not at runtime. So type inference is entirely a compile time facility, as we can see in this particular case. So you can use this for local variables. So for example, you can say var greet equal to hello, but you can also use this for other purposes as well. For example, suppose you had a list of string names, let's say, is equal to arrays dot, let's say, as list, and I'm going to say some names over here that I want to bring in. So now that I have a bunch of names with me, I can use this in a for loop for string name coming from names, and I can then say, for example, something along the lines of output name over here. But you can use a type inference in this case as well. So for example, you can say, hey, why not make this a var? And you can definitely use it for that local variable. Similarly, you can come back here and say var and you can use that in the for loop as well. So you don't have to say what the type is if you don't care about it. And likewise, if you're using a try, and in the case of a try, you are saying, let's say file reader, let's say file reader is equal to new file reader, like so. And I want to write the code with the file reader. And let's say I'm just reading the same file here that I am working with. So I say sample.java, like so. Now, obviously, that's going to expect the exception to be handled, but I'm impatient, so I'll simply say throws exception, like so. Now, in this particular case, you can bring in a file reader, which is obviously coming from java.io.star, and you can see that code actually works. Similarly, what you can do is you can put a var in that context as well, because again, the type of the variable is known based on the context. So type inference is useful when the type is really obvious. Now, clearly in this case, there are a couple of things we need to be aware of. So let's say string greet equal to hello, and I want to output the greet. So this code actually works, no problem. And in this case, I can take the variable type and put a var in there, and that's perfectly fine. However, if I take the greet variable and I say greet is equal to hello, the code works, but I cannot use a var here. So that's a no. Why not? Because the type is not known based on the context. So when you use a var, the value must be assigned on the same line. If you don't define the value on the same line, then this is not going to be able to infer the type. So even though the code with the string defined on one line and assigned on another line works fine, you cannot use a var for type inference in a case like this. And that's quite meaningful because looking at that line of code, the compiler should clearly know what the type is. And if you haven't given that information, it's not going to work. So when should we really use type inference? Use type inference only where the type is 100% clear to the compiler and to the programmers. So this can be used for local variables. You can use it for a for, you can use it in a try, and so on. But what about a field? I'm going to say not yet. I'm not saying no, but I'm saying not yet. Java has not introduced type inference for fields at the moment. So if you say max equal to 100, and of course, this is going to be okay right now, as you can see, and the compiler is happy with it. But if you were to go back here and say a var, the compiler doesn't permit it. Var is not allowed here, it says. And I am going to say not yet. So I hope eventually Java allows type inference for fields. There is no reason why type inference cannot work for fields, and I sincerely hope that happens someday in the future. So, not yet. What about for parameters? I do want to emphasize one thing. There are a few languages like Haskell which allow type inference for function parameters. But languages like Kotlin and Scala don't. The reason is when the type inference works on parameters, the signature of the function can vary based on the implementation of the code, which is not a good thing to do in general. So as a result, languages like Haskell, even though they provide type inference for function parameters, some languages don't, and Java doesn't. And I really, really hope Java never offers type inference for the parameters. So if you say int A and int B, like so, and if you were to, return, let's say in this case, let's say return A plus B. Well, while that code is fine, you cannot use a var and you cannot use a var here. That's not permitted in the case of Java. So, and as I said earlier, I really hope Java never has type inference for parameters because that can be pretty confusing. I'm not a really fan of that, and I'm happy with the way Java is today for that reason. So, with all that said, I'm going to talk about some caveats when it comes to using type inference. I wanted to see if there are any questions or comments at this point about anything we talked about type inference in previous versions of Java, type inference in Java 10. What are some of its limitations? What are some of its capabilities? Just about anything. So I want to just pause for a minute and see if there
Yeah.
are any questions or comments.
So actually, not yet comments. But they're like emotions mainly. So first of all, the main emotion is how you actually deal with Vim or VI. So I'm so much impressed. I haven't tweeted about it. And people are asking why not Emacs, for example. This is the regular question. And yes, and people are just, for now, everything is really clear. So thank you very much. Let us actually go continue. So we are like so much excited. The way you present is very exciting. So we are excited. Thank you so much.
All right, sounds good. So let's talk about a few caveats we have to be really careful about. Type inference is great to have, but it doesn't mean we should use all the time. And I really wish the compiler gave us a better control over things. And this is where we got to be very, very careful because the compiler won't stop us making some mistakes. We have to be prudent not to do it. So let's understand a few problems we have to be careful about. So suppose I said list of, let's say, integer, and in this case, I'm going to say numbers is equal to new array list of integer, and I'm using a diamond operator. If I say numbers dot add, and I say add 1, and I'm going to add 2 as well, then I'm going to output the numbers. Now, clearly in this case, the result is 1 and 2, as we can see in here. But what if I were to say numbers dot add, and I'm going to say hello, like so? Now, clearly we know that will not compile. So that's good. But what if you said, in this case, instead of list integer numbers, if you said a var numbers, there's a name for this in English. It is called bad idea. Now, why is this a bad idea? When you compile the code and run it, it still produces the result you expect. But what was the type of numbers, and what is now the type of numbers? We need to ask that question. Well, it turns out the type of numbers here, numbers is a reference, as we know, is a reference of type list of integer. But then over here, what is it? Numbers is a reference of type list of object, unfortunately. Why is it object? Because remember, it can only work based on the context. If you ask me honestly, I really wish this was a compilation error. But unfortunately, that's not the case. So when you run the code, it still produced 1 and 2. But if you come back here and you said hello, notice the compiler doesn't stop you at that point. And the reason is the inference really worked based on the context it knows. So I'm hoping we will have tools in the future, maybe something like a JLint or FX, tools, FXCOP and such, which can look at this code and say, hey, don't do this. This is a bad idea. You shouldn't really use a diamond operator and type inference with it. So don't do that. That's one thing you should be careful about. So do not use type inference with diamond operator. Another thing is, when you're dealing with collections, now I want to emphasize one thing. What I'm going to show you here is not a problem of type inference. This is a problem that's been in the code all along. It only gets worse because of type inference. So this is not a problem introduced by type inference, but it gets only worse. So let's take a look at an example. Suppose you had a list of integer over here, and if you said numbers is equal to, let's say, new array list, and in this case, I'm going to say arrays dot as list 1, 2, and 3. So I have an array list. I'm going to output the numbers given to us, and you notice that the value is 1, 2, and 3. But what I want to do now is to say numbers dot, and I'm going to say remove 0, or let's say remove 1. So when I remove 1, notice what it removed. It removed the first element in the collection. So the item 2 was removed. So what was the result of this call? So we can remember it. This was 1, 2, and 3. On the other hand, this was 1 and 3 as the result. Now in Java 5, they did a mistake. And that is, when you take this particular example, suppose you had a collection in here. Now when I run the code, notice the output is 2 and 3. So this was already a problem in Java. So when I use a collection, the result is a 2, 3 if collection is used. And in this case, if list is used, it's a 1 and 3. So you can see the discrepancy in the result already. Now the question is, suppose your code contains this like here. And if this is the way you wrote the code, what is the output? The output is 2, 3 as we saw. So that's great. Now you come along and you modify this code and you say over here a var like so. Now the question is, what's going to be the output? Notice the output is not a 2 and 3, but the output is a 1 and 3. What is the reason for it? The reason for that is that numbers that you see here was a collection of integer. But what is it now? Numbers now is a list, well, actually, an array list of integer at this point. So that can be really, actually, it's even worse, right? Array list of object at this point, which is even worse. But if you had integer like so in here, so like this one, integer, and oops, let's try this again, integer. And if you had integer over here, then you may be tempted to use the var, but keep in mind that even now it's a problem because numbers, which was a collection of integer, becomes a collection, array list of integer at this point in terms of its type. Once again, we got to be really careful with code like that. So again, use caution. Same concern appears between base and derived type. We got to be careful about it as well. For example, suppose you had a base class, we say b is equal to new, let's say new derived, derived. And now, of course, you say b dot some function f1. So we have a class called the base, where the base class contains, let's say, a public, let's say, void, and we'll call this as f1, which is a function. Then you have a class, let's say, derived, and the derived class is going to extend from base, but within here you have a public void f2 as a function. Now, in this example, you can see that the code is going to be fine when you call the function f1. So if I were to output, let's say, okay, as a value here, you can see the code is quite happy with it. But as you know, b.f2 will be an error because the reference type is a base type. You cannot call the function f2 on it. However, if you were to go back here and say var, then you notice that it is okay. And why? Because this is no longer an error, because the type of B is not a base, it's a type of derived based on the context. Once again, we got to be careful about what the type is, otherwise, we're going to be disappointed. Well, lambdas, as we know, are special. Lambdas are often backed by functional interfaces. So if you had runnable is equal to, and I have a lambda, output running, and if I were to say runnable dot run like so, you can see that it says running. But what if I got tempted to put a var? Well, the short answer is no, you cannot do that. Why not? Because lambdas don't have type. It is based on what you assign to is how the type of a lambda comes about. So for example, you could also have, so this is not possible, like I said, that's a compilation error. The reason it's a compilation error is, as you know, this can be runnable, but the same particular lambda could be my interface, whatever that is, and I could say, my interface, and I could then come back here and say my interface dot, let's say foo, for lack of better words, where I could say interface, let's say my interface, and I could simply say void foo as a method within that particular interface. As you can see, this exact lambda, no difference at all between the two lines on the right side of the equals, as you can see. So given the same right side, we are able to assign that lambda to two separate variables. So in other words, the context of the type is on the left side, not on the right side. This is why you cannot put a var in here. That is not permitted. Now, when I say it's not permitted, you know how some programmers will never take no for an answer. So what do they say? They say, let me show you how they say. And then they do the following, right? They put a var here, and then they put a runnable, and they write the code like that, right? And I am going to simply say, heck no. So that's terrible. This makes the code even worse, because what's the point of using type inference when you have to specify the type after all? So this makes no sense at all, even though the compiler permits that. So seriously, don't use var with lambda expressions to store them. It makes zero sense whatsoever. Well, that's all great so far, but let's talk about some benefits as well. We talked about the do's and don'ts, but what are some of the benefits of using this? Well, the first thing is it reduces clutter. Now you may say, really? Where does it reduce the clutter? If I were to say string greet is equal to hello, like so, and if I were to say output greet, now if I were to replace that with a var like so, what did we gain? We saved exactly 3 characters. So is that a big deal? Not really. But sometimes we work with code from hell, isn't it? Where the code has something like this, a map of something along the lines of, a string, comma, and then a map of maybe a integer, comma, list of, let's say, person, and so on. And when you have a code like that, that can be really painful, isn't it? Because if you look at that code, and then of course you ask how many more of those angle brackets you need. Well, you go home and your family asks you, what is all this bruise on your arm? You say, that's working with all these arrows throughout the day. I got them scratched. well, that code can be really hard to understand and hard to maintain. So the point really is, why should we really care about all the type when we can deal with a var and then you can specify that really? So when the code becomes clumsy, when the code becomes really tiring, we can benefit from a var so that we don't have to be dealing with all that mess of the detail. So it can be really less cluttered. This is one of the places where you're going to really benefit from the type inference. Now, one of the things I want to emphasize is this. To me, writing a code on a particular application is like living in a city. Now, when you're new to a city, in my life so far, I've lived in multiple cities. And when I move to a city, everything is new. I don't know where the post office is. I don't know where the library is. I don't know where the park is. So I have to look up for directions. And when I'm driving, it says turn right for the library. I'm like, good, that's helpful. But once I live in a city for a year, I don't need those directions because I know exactly where things are. In a lot of ways, code is very similar to that. When you're new to a project, you don't know what these things are, what the types are. But when you work on a project 10 hours a day, continuously, you know the domain, you know the context, you know the type. So, in other words, all the type information becomes a noise after a while. What if you can have a var? You don't have to see that a noise in the code. But for those who are not familiar, you hover the mouse over the variable name and the IDE displays the type for you. Now we have the best of both worlds. For somebody who don't know what the type is, they can look at it in the IDE. For those who are familiar with the type, it doesn't really bother them. So that becomes a lot easier. Similarly, it becomes really easy to evolve the code. And to me, programming is a series of mini experimentation. I'm experimenting with the code continuously. And as I'm experimenting with the code, I don't want to work with the type too early on because to me that's a premature optimization. I want to figure out what the function should do. And the less type I put in the code, the easier it is for me to evolve. You kind of wonder, why do programmers like languages like Python? Part of the reason is the language allows evolution much more easily than language like Java. But one way we can make Java easier to evolve code in is by removing all the things that become a burden to us.
By the way,
Also,
people are asking here. So,
uh-huh.
what about the nested types? So, I say not exactly nested types, but nested like generics. What will be like a map of strings, of maps, of I would say like templates of T and V. So, would it actually get it?
Actually, it is because the compiler is extremely smart. And I've realized over time, compiler is always smarter than me. And you know why? The reason is a compiler is a machine, and I'm a human with emotions. I'm intelligent, but I get confused. The compiler is methodical, it's very thorough. So the compiler can perform a lot better analysis than I can as a human. And that's one of the reasons why this is quite reliable, and it's able to infer the type pretty. And of course, if the context doesn't exist, it's always going to tell you that. But when the context exists, it can figure it out pretty nicely.
Oh, yes. Yeah, thank you. Let's go ahead.
So, given that, of course, the question then is, what about reusing, code? Let's take a look at an example, if you will. Suppose I had a code like the one we had earlier, right? So, create people. Let's start with that right now. And in this case, what I want to do is I want to perform a grouping by operation. So, let's take a look at an example. Imagine for a minute you have a list of person, we'll say person people one, and pretend that these are different lists. And I have a create person right there. But then I say people one dot, let's say, stream, and then dot collect. But what am I going to collect it using? So in this case, in the collect, I'm going to bring in the collectors in here, and I'm going to say over here, let's say grouping by. And what do I want to group based on? Let's say given a person, I want a person, let's say a dot, let's say get name, and I want to group them based on the name of the person. And I'm going to go ahead and store output, let's say, that's all I'm going to do is simply output that particular collection at this point. So when I run the code, you can see that it is actually going to group based on the person itself. Let's see what I did here. Create people rather, not create person. So let's fix that. So here we go. So when I run the code, you can see it performs a grouping. Great, we got the output like so. But what if I really wanted to do the following? Suppose I have a list of per people, let's say 2. Pretend that it's a different list. And now what I want to do is to use that code right there, but this time on the second collection, if you will, on the people 2. Now you look at this code and say, oh, Venkat, you are duplicating the grouping by function. Why don't you reuse it? Really great idea. So what I want to do is to say grouping by, and the grouping by function that you write here, and I want to come back and assign that to a variable. And then I will say over here, grouping by name, let's just call it like so. And similarly, I'm going to say grouping by name. Very wishful thinking, isn't it? But the question is, what is grouping by? If you're using an IDE, you could probably just click on the IDE and it puts the type. But the question is, why? So if I were to say, what am I going to put over here? So the type grouping by name is what I want to write is equal to. But what in the world is this particular type? What do I specify here? We could waste our time on that. Or you say, I don't care. All I want to know is I am saving that variable into I'm saving that part into a variable. I don't need to be spending my time and effort on that one over here. So essentially what you could do is you can take the grouping by function and you can assign that grouping by into a variable like so, and have it take care of the details for you. In this case, of course, you're dealing with a person, right? So you could say that's a person because the type information is necessary. But notice it was able to decipher the type for you like so. But if you're curious, what is the real type of that variable? Well, you can try to find that out in the code. For example, if I say grouping by name.foo, and you can see what the type information tells you. Did you notice what the compiler said? Foo is not available on a variable of type. What is it? Collector, person, question mark. Even the compiler doesn't care what the type is at that point, and then the rest of the stuff. So in other words, I don't really need that information. It is good enough for me to know that I put that into a variable. It is really less important what that level of detail is. And so you can simply use a var. So that becomes really easy to reuse stuff in your code. Of course, it's a lifesaver when it comes to debugging. You can simply store things into a variable temporarily and you can move on. But one other thing I want to really show you here is a targeted intersection type. And that is something really, really powerful. So what's a targeted intersection type? If I were to say a list of, let's say, in this case, object. I know, not too often. But we will say things is equal to, and I say arrays dot as list, 1 and hello. Now, in this case, I'm going to output, let's say, things. Now, as you can see, it's one and hello. But if I were to change this to a var, the question is, what is going to be things? Well, as it turns out, things actually is a lot more than what may meet your eyes. This goes back to your question earlier about the compiler inferring the type and being able to. Compiler is extremely smart here. So if I were to say things.add, let's say, and I'm going to add, let's say, new sample. Now, one quick detail. Let's use this code right here. And when I run the code, you can see that, it didn't give a compilation error, right? It just gave us a runtime error because you're not allowed to add to an arrays as list. But if I said over here something along the lines of new array list and an object, let's say, and if I'm going to do it this way, you will notice that the code will not give you any error at this point. Now, on the other hand, if you were to take this code, but if you replace this with a var like so, then guess what happens? You get, in this case, you are able to say things over here. But once again, I want to go back to this code right here that we saw a minute ago. So if I were to say a var like so, guess what's happening? You get a compilation error. Now you may wonder why you got a compilation error. The reason you got a compilation error is, if you carefully look at the type, it says the variable is actually a list. But list of what? List of object, serializable, comparable, constable, const desk. Oh my goodness, what happened? This is called the intersection type. So the compiler is very smart to determine the type of the list is what's common between 1 and the string hello. So the common between integer and string is that it is serializable, it's constable, and so it comes up with an intersection type behind the scene. So the compiler does a lot more extra work than we may assume. And one other thing is, you can also have an anonymous type internally deferred as well. So as a result, even though we cannot specify the anonymous types in our own code, the compiler knows that, and the var can be anonymous type. That's a little bit less important now today with the records, but something that's interesting to take a look at. But one thing to keep in mind is var is not a keyword. That's kind of the fun part. So if you really, really want to mess with people, you can do this. And when you see this, notice that the compiler does not complain at this point. I'm not suggesting you write code like this. So the reason is var is not a keyword. So it's a contextual keyword, not an absolute keyword. So as a result, you can have variables with the name var if you choose to in your application. That's not a problem. Well, a couple of small details to wrap this up. And that is, in Java 11, you can use a var for Lambda parameters. Now you may wonder, why in the world you may want to do that? And is this really useful? It turns out it's very useful for annotations while using type inference. Let's revisit that again. So if I said var numbers is equal to arrays.asList, let's say 1, 2, and 3. As you know, you can do the following. You can bring in javax dot, in this case, of course, validation dot constraints, let's say. So you can bring in the following into the code, isn't it? You can say numbers dot for each, and you can specify final, not null, for example, and then you can say integer element, and you can output the element like so. So that syntax is permitted in the code, as you can see. So, but if you wanted to use type inference of Java 8, you could not do that. That is not permitted. Because if you're using type inference, you can use type inference without any annotation. or without any final. But you're not allowed to use annotations with type inference. But what if you really want to use type inference and with final or annotation? Then you can put a var like so. So when you use a var allows you to use type inference with annotations and with final. So that is an improvement in Java 11. Now, there are some restrictions. If you use a var, you have to use var for all the parameters. So, for example, if you had said numbers, let's say dot stream, and then you say dot reduce, let's start with a 0, and I say integer total, integer e, and I'm going to return a total plus e like so. So the compiler is going to be happy with this, as you can see, because we are using the type for both the parameters. That's perfectly fine. Where did I miss that one? So integer total and integer e, and of course that's going to be, there you go. So that's perfectly fine. The compiler is not having any problem with it. But if I wanted to, I can also say total and e, and I can write the code like that as well, use full type inference. But I can also do a var, and I can use a var like so in this case. And that's perfectly fine too. But what I cannot do is I cannot say integer, let's say integer total and var e. That's not allowed. So if you're using a var, you have to use a var for all the parameters of the Lambda expression, and you cannot just use it for one or the other. So that's a no. So some little limitations like that. Either use type inference entirely, or you use the type entirely. You cannot mix and match them in the code. Now, going to the conclusion part, let's talk about a few recommendations we should be careful about. I am a big fan of type inference. Part of the reason is I've used type inference in other languages, even C++ as an auto for type inference. C# has had var. Kotlin has type inference. Scala has type inference. Haskell has type inference. A lot of languages have type inference. I'm really happy that type inference is available more so in Java today than in the past. But that doesn't mean we do this all the time. Use type inference where it is extremely clear what the type is. Don't use type inference with the angle bracket, the diamond operator. Don't put the type in a name. This is something I want to emphasize, because sometimes people are guided by this. They say numbers list. No, don't do that. Numbers should be numbers. Don't try to embed the type in the variable name. This is where we are clinging on to the type and not let go. Make sure the type is exactly what you want. Don't assume it is what it is, that you think it is. Make sure it is really what you think it should be. So, especially when you have a derived versus base, ask the question, if you really want type inference to treat it as a derived, specify the type unless you are absolutely clear what the type is. If you have the slightest of doubt, don't use type inference. Now, if your developers are not happy with it, don't force it on them. Let them take the time to get comfortable. One place where you can use type inference is in test, because the tests are usually small amount of code, and you can use type inference in your test. And when developers become really comfortable with it, you can then slowly start using type inference in your code over time. Use var for temporary variables, for just intermediate variables for debugging purposes. Use var when you're trying to reuse a body of code, and simply assign it to a variable. The type is not that important because you can abstract it out in your mind. The specifics of the type is less important at that point than the fact that you are reusing this particular variable. And finally, use var to annotate parameters to Lambda expressions when you want to use type inference as well. that's a really nice place to make use of type inference. So I want to answer the question: is type inference our friend or is it a foe? I'm going to say it's a tool. That's what exactly type inference is. It's a tool. And we should be able to use that as a tool. And when you use it correctly, it's our friend. When we use it incorrectly, it becomes our enemy. Hope that was useful. I want to really thank you for the time. Thanks for the organizers of the conference to have me here. I really appreciate it. Hope that was something you can put to use as well. Thank you.
No worries. Thank you very much. Thank you very much, dear Venkat.
Yeah.
It was amazing. Unfortunately, we have no time to answer some questions in the live stream, but please go to the Zoom and continue our discussions with all the participants who are interested in this interesting topic, I think. And thank you very much, Venkat, again, and thank you very much, Mitya, for the support. As we say,
here,
yeah,
thank you.
yeah, it's a great honor for us to have Venkat as a first pilot and you as a second pilot. That's amazing team, I think.
Wingman, yeah.
It's a great honor for
wingman.
us to have you both on board this year. Thank you very, very much. Bye-bye.
Yeah, it was always great. Yeah, I'll see you in the discussion zone. Yeah, thanks for a lot of discussion will happen there.
I'll look forward to coming to Zoom in a few minutes.
Yes, exactly.
Yeah.
Thank you.